you discuss the learner attitude sphere in your metaphor of the learning cosmos, which is composed of the three components: self-efficacy, growth mindset, and metacognition. Could you explain each of these components to us?
Definitely. So one of the things that we know from research now is that your cognitive abilities, of course, they play a major role when it comes to learning, but how much you believe you can achieve also plays a role, you know. And we've known that for a couple of decades now. And there's also the idea that you need to systematize and organize yourself to learn well. So you need to know how to learn, or even better, you need to learn how to learn, which is the idea of metacognition. And metacognition is something that comes from the research of John Flavel, many, many years, you know, decades ago. And being able to think about your thought process and learning how to learn and applying the right strategies is fundamental nowadays, because we talk about lifelong learners, right? We want people to keep on learning because we always have many things to learn. And so that's the idea of metacognition, being able to adjust, to reflect on the things you do to learn so that you can learn more effectively. And then growth mindset, which is something that has recently become more controversial, to be honest, you know, because of some meta-analysis, some interventions at school. But it's basically the idea that we fall somewhere along the spectrum, let's say. And the two extremes of the spectrum are growth and fixed mindset, you know. So on one side, you have a more growth mindset. Again, it's a spectrum. It should never be looked at something as something binary. It's either this or that. It's a spectrum, right? And it depends on what you're doing. It depends on your mood. It depends on many variables. But the idea is that if you have a more fixed mindset for something, you believe in innate talent, let's say, or intelligence, which means that you either know how to do it from birth, and there's no use in applying effort and commitment, or you simply can't do it, right? And the idea, if you are approaching, let's say, the other end of the spectrum, and you have a more growth mindset, basically it tells you that the more you apply yourself, the more you try, the more you actually make an effort, the better your chances, and the more you can learn more effectively. And then what we should be doing, according to the research, is trying to help our students to develop a more growth mindset most of the time. The problem is the research now shows that a lot of interventions based on this idea of growth mindset, they have not been successful, because I think mostly because of the design of the interventions. You know, it's not something that you can do punctually, like a workshop about growth mindset, and suddenly everybody will transform their mindset. It's something that needs a certain frequency. It has to be constant, and there has to be somebody encouraging students along the way, reminding them that they can learn, because this is really the basis of neuroplasticity, that we can always learn, right? And self-efficacy has a lot to do with organizing oneself to achieve goals, you know. And this comes from the research of Albert Bandura, who left this world a couple of years ago, recently actually. And he mentioned that if you know how to organize your time, to prioritize your tasks, you know, to find the resources that are necessary for you to achieve something, then you are a self-efficacious person. And many times what stops our students from learning more effectively is that they cannot organize their studies. You know, they are always expecting their teachers to give them what to do, to tell them how to do things. So I think those things, they match very well, you know. If you are a more metacognitive person and you learn how to learn, that means you have a more growth mindset, let's say. And that means that you can better organize yourself and learn more effectively. So that's why I think beliefs and attitudes is really the right label for those concepts that I've just mentioned here.
Yes, that's it, exactly. Yeah. And you just outlined the concept of metacognition, which we call the big word starting with letter M. And this phrase is frequently used in educational neuroscience. How can we use this ability to enhance our learning process?
Yeah, I think it's the first thing that we need is to become aware of our learning process, and this is really what John Flavel, the main author who coined really the concept of metacognition. He says that we need to become metacognitively aware. So we need to have metacognitive awareness, because then we see what we are doing and what we are not doing. And then we have to start asking questions. If I keep doing what I'm doing, does it mean I'm learning well? The other thing that we should be doing is analyzing if we can change the experiences that we go through to learn something. And that's really the second thing. It's, once you become metacognitive or more metacognitively aware, then you have to change your metacognitive experiences, how you can design a better learning experience, let's say. So I've always, studied 3 hours after my lessons every day. So I really, I do my homework, I study, does that work? Am I wasting my resources? What are my outcomes? Analyzing really the data that you have access to. And then you change the experiences to see, well, has anything changed? Is it better now? Is it worse? So being metacognitive is really experimenting with different strategies and asking a lot of questions. And finally, metacognitive regulation, which means that, okay, so now I have a better picture of how I learn, my process of learning. So what are the adjustments that I have to make sure that I'm using the most effective strategies? So that's why being more metacognitive really means questioning things, So I like the idea. That's why I use Socrates a lot in my book, because I think don't take things for granted. Sometimes you simply do things out of tradition, maybe, because that's how your teachers told you to do things, your parents told you to do things. But then have you tested other strategies? Have you looked at the science? Because, being metacognitive can be, it could actually backfire if you don't look at the evidence. Because if you just think, well, why don't I do that? And then you feel that you're learning better, but maybe that's your cognitive bias speaking, So you have to look at the evidence and then look at the new concepts that we have. But still, it's about questioning the things you do as a learner. And as soon as you do that, and you have a better profile of you as a learner, you can make the proper adjustments to learn more effectively. That's why I think we should all be more metacognitive, not just follow blindly what we've been doing forever, I think.
I think even teacher feedback during the metacognitive process is very important. I think it's really crucial.
Because of the biases, everybody's biased, and sometimes we feel that what we are doing is actually quite effective because we don't have the perspective to analyze our outcomes, because it's too close to us, let's say. So if you have somebody from a different perspective, somebody with more expertise like your teacher, they can give you a more objective assessment, let's say, of your outcomes, and then use your teachers. I mean, we as teachers, we have to give feedback to give our students the tools for them to become more metacognitive. Otherwise, it's almost like dancing in front of a mirror, if you think about it, So if you're trying to learn how to dance, but there's no mirror or there's nobody filming you, you don't really see what you're doing, So you need a different person's perspective to actually, oh, that's where I'm getting this wrong, so I can make the adjustments and be a better dancer. Yeah.
So in one of your lectures, you included the following quote, which struck me. Kids are in an educational system that prioritizes knowing the digestive system of a worm over the functioning of our brain.
Yeah.
And when I read it, I said, this is so true. Why did you use this quote in your research?
Yeah, because you know what, Erika, I've been lecturing and delivering workshops for a while now, and one of the things that really strikes me as very strange, I would say, is that most of us educators, we don't know much about the brain. We work with the brain. That's what we do. so this is our main, let's say, client or student or customer is the brain, because the brain does everything, you know. And whenever you ask questions or whenever you introduce new concepts about the brain, people sometimes they get overwhelmed or obsessed, fascinated, because they don't remember much. If I ask them, what did you learn about the brain when you were a student, you know, in high school, for example, or elementary school, they say basically nothing. And that's the thing. So we spent a lot of time learning lots of things about biology, for example, that basically concern other animals, and, you know, things that, sure, they are interesting, especially if you're a geek like me. I mean, I loved learning about the digestive system of worms and other animals, you know. But still, I think we need to dedicate a lot more attention and time to learning about our own brains and how we learn. Because if you understand how it works, then you can start making changes. You know, you can, if you become aware. And this is something, for example, a lot of people are unaware of the fact that our working memory is very limited, you know, incredibly limited. For example, that, you know, attention and memory, they are expensive resources, let's say. I mean, so you don't have a lot, and you know, for you to learn, you need them to be working properly, right? And one of the things that we do, because we basically designed our entire educational system around that, is on content, lots of input, you know. So that's not very compatible with how the brain works, you know. There's just too much content to be covered in a very short period of time, and we cannot possibly do that. Physiologically, it's impossible, because we don't, you know, the brain doesn't work like that. So can you imagine if teachers were more aware of that? If they were aware that, oh, this is simply too much information. There is a concept that we use all the time. It's called cognitive overload. So basically what we're doing in the classes that we teach, we are overloading our students' brains all the time, because there's just so much to learn. We have no breaks. We don't revisit things with the frequency that we should, you know, like spaced repetition, for example. And then what happens is we get surprised when the students say, I don't remember anything. You know, of course they don't remember anything. They were overloaded, you know, basically drowned in this sea of information, you know. And that's the thing. If you learn about the brain, then you can start, I don't know, coming up with better strategies, let's say, of how the students can learn more effectively. And unfortunately, even for kids, I think the kids themselves, they have to understand, you know, they know about their bodies. They know about if they want to do sport, you know, they know that if they try very hard, if they work out too much, they are probably going to get injured, you know, but they don't have the same notion about their brains. They feel like a lot of students are under the impression that they have to keep on studying and memorizing and doing lots of homework, and that's the way to learn. But that's not true. We know that from a neuroscientific perspective that it just doesn't work. So again, if we could, I don't know, maybe tweak a little bit the curriculum when we're teaching biology or science, and make sure that the students know a lot about their brains, maybe they can actually start becoming more metacognitive, implementing new strategies, right? So that they can learn more effectively. And I think that's the idea that we should try.